Welcome back. So now that you already know what kind of fundamental data structures you have which are native to Python, basically data structures that you can directly take for granted in Python, we are in this video going to introduce a library called Pandas. Pandas stands for Panel Data Analysis, which basically uses lists, dictionaries and arrays from Python or NumPy to create something called a data frame. A data frame is a supercharged data storage structure which is available through Pandas, and you can think of it as Excel for Python. So if you know how to use Pandas very well, you should be able to do pretty much everything that Excel can do and more in a programmatic Pythonic way. So let's get started. First of all, in order to run the notebook, we'll have to import a bunch of modules. So we are basically going to import pandas, and we're also going to do some plotting. So we are going to import the plotting library, which is called matplotlib. Let's run that. So essentially pandas lets us read, process and analyze any kind of tabular data. So when we say read, what we mean is that pandas has parsers for multiple different file formats. You can read from CSV files, you can read from Excel sheets, you can read from databases and so many other sources. You can process that data once you have taken care of the file IO. Not only can it read from all of these different formats, it can actually also write back to all of these different formats. So it takes care of file IO as well as it can do the processing of the data, which is basically most of the bulk of Pandas functionality, essentially processing, cleaning, manipulation, and all of that. And finally, it also has a few things which we can use for analysis. This is where things get into the mathematics and statistics part. So the univariate, bivariate, multivariate analysis techniques that we have briefly covered in an earlier video, you'll see that most of them are doable right within Pandas. So the primary entry point into Pandas is, like I said, a data frame. So let's take a look in a little more detail on what a data frame is. In general, you can just consider a data frame as the Python equivalent of Excel sheet. So these are basically labeled two-dimensional data structures. What do we mean by two-dimensional data structures is that we saw that we had lists which were simply indexable by a certain position. That is, if you had to access a particular value in a list, you only had to know its position. Whereas most of our data, as you know, is going to be tabular. So you can access a particular cell value by its row position as well as its column position. And these don't even have to be positions. We have to have them as we can have them as names, not necessarily integers or numbers. So that's what we mean by saying that it's a labeled two-dimensional data structure. What it means is that the rows have their own labels, columns have their own labels. Just like a dictionary has labels and values against them, or keys and values against them, pandas rows are also like dictionaries and columns are also like dictionaries. We're going to see that in a little more detail in just a little bit. And it's basically in spirit very similar to an Excel worksheet or a relational database table. So essentially, pretty much whatever you can do with rows and columns is what you can do with pandas. And by now, we have also spoken in quite some amount of detail about the details of tabular data. But let's also revise it just for the sake of completeness. So we know that each row represents one sample out of all the data points that you've collected. Each column contains a different variable that describes the sample, or which is rows. Essentially, each column is an attribute of the thing that you're measuring. And the data in every column is usually the same data type. That is, if you're measuring somebody's height, then the whole column is more likely to contain numbers rather than strings, and so on. So that's basically what creates a data frame. It's essentially just a table, and it can be created in many ways, such as using another data frame, or using a NumPy array or a composite of arrays that has two-dimensional shapes. So as we've seen in the previous video, we have a bunch of two-dimensional shapes. For example, the nested list example, if you remember, which was a list of lists, and each internal list had the same amount of elements in it. So that represents a table. At the same time, a dictionary which has keys as the column headers and the values as lists which contain the column values, that also represents essentially a two-dimensional data set which can be used to create a data frame. You can use a pandas series also. Now a series is essentially just one column or one row of a data frame. So if a data frame is a two-dimensional structure, a series is essentially its one-dimensional equivalent within the pandas ecosystem. It can be produced from a file such as a CSV file or an Excel file. It can be also created from a table, and we have already covered how it can be created from a dictionary. So these are some common operations with pandas. Let's say that this is one particular data set that we have, which contains, again, it's actually a dictionary. So you can tell that from the braces. We have enclosed a bunch of things within braces, which means that it's a dictionary. We have keys, colon, values. So essentially, this is a dictionary which has three key value pairs. The first is name, the second is score, and the third is attempt. And if you look at the values of each of these keys, they are essentially lists of the same length. Whatever is the length of this particular sequence of names, that is the same as the length of the sequence of scores and of the attempts. And let's say that we have another list which is just a list of letters from A to J. So that's 10, and all of these are also 10. So essentially these are interpreted by pandas as column headers and the values of a given column. We can just put the dictionary within the pd.data frame caller over here, and we can say that we want the index to be these labels. So let's just run that, and we see that we get a data frame. This is essentially our data, which is tabular, and we saw that name, which was a key, became a column header, score, which was another key, became the next, and attempts became the last. And the values inside each of these values, they became the contents of the column itself. Now here's how you do some of the common operations within a data set. This is the whole data set containing 10 rows. If we just want to see the top few rows, we can just do a df.head. Now df.head, by default, when you call it, it's going to show us the top 5 rows, but we can give in any number over here. I can say just show me the top 2 rows, or I can say show me all 10 rows, or I can just say show me 8 rows. So I can just pass it an integer, and it's going to show me the top k columns or the top k rows of a particular data frame. The same thing I can also do using an iloc function. Iloc is essentially integer location. So essentially I'm saying that give me the first 3 rows, and that's it. So that basically gives me the first 3 rows. Right? This is how you can slice out different rows of a data frame. In order to get a column, I can just remember that data frames also act like dictionaries. So essentially, just like you get a key value pair from a dictionary, this is how you get a column from a data frame. This is going to give me the score column out of the data set, which as you see is 12.5, 9.0, 16.5, all the way up to 7.5. So let's try that. And there it is. You see, in both those cases, whenever we try to get a row, the index, which is A, B, C, D, E, F all the way up to J, remains the same. What that means is that each location, instead of being indexed by a number, is being indexed by a letter, right? So that simply is useful because sometimes strings or names are easier to remember than numbers. So just like in a list, you have positioning by numbers. Here you can have positioning by arbitrary strings. So those are called the index of a data frame. You can also filter a column which says that, let's say I want somebody whose name is Emily, and I want to take that person's score. So we know that there is exactly one row which has name as Emily, and I want to get this particular value out of it. So I can use that as a filter. I can say that filter the data frame df such that the name column equals Emily, and from that get the score out. So there it is. That basically gives me the score of Emily. Easier way to break that down would be something like this. Let's say that I simply do df.name equal to Emily. What this is going to return is a set of Boolean values, which is whether the name is Emily, for this particular row and for that row or not. And essentially there is only one row where it is true. And when I use this to slice my data frame in general, it's basically going to give me all those rows where the name is Emily. In this case, it's just one row. So that gives me the first row, the only row which contains the name as Emily. And out of this, like we know this is how we get a score or we get a particular column out, we get the column over here. So there it is. It's basically 9.0. And here's how we edit a cell. When you want to change the particular value in a cell, we just do an LOC operation on it, which stands for location. So what this instruction says is that find the location D and then find the column score and set its value to something. So what this means is that in my original data frame, the D column is James and the score is 6.0. What I'm going to do is set the score to 11.5. So when we do this operation, and look at the data frame again, we'll see that the score of James is going to be 11.5. So let's try that. There it is. So we see that the score of James has become 11.5. In order to do that, remember what we had to do was find the index value, which was D, and find the score or the column that we wanted to change. And we just assign the desired value to this output. We have already seen some examples of logical filtering, but let's take a look at some of them again. Let's say that we want to take all the elements or all the rows of the data frame where the score is greater than 15 or less than or equal to 20. In the sense that we want to find all the scores, all the people who scored between 15 and 20 marks, both values included. So what we are saying is that create a Boolean value, just like we had a Boolean value over here, which contains true for all the scores which are greater than or equal to 15, and do an logical AND with another set of Boolean values which have a score of less than or equal to 20. So when we run this, we see that Catherine, Michael, and Jones are the only three people who got scores between 15 and 20. And if you verify this from the data, you will see that it is actually correct. The next step would be to do some sort of arithmetic on the column. This is useful when we are trying to calculate our univariate statistics or aggregations and grouping, which we will consider later in this particular video. You can just take the column. Remember that this is how you access a column, and call a sum or a mean on it. So let's say the total number of attempts is basically 90. So this is how you can do it. And if you try to take the average score of the entire batch, that's 12.75. Now, in order to motivate some of these examples further, what we are going to do is look at a case study. So Kaggle is an online platform which runs competitions, which runs basically data science competitions. If you go to this compete tab over here, you'll see that there are a bunch of competitions that Kaggle hosts. Essentially what they do is that if a company has a lot of data but they don't know what to do with that data and they want that data analyzed, or they want some sort of predictive models built with that data, they will host a competition for that in exchange for a fee from the company. And what they do then is that they invite practitioners such as yourself to compete on these data sets to come up with a best possible model. And whoever is the winner gets a little prize from the organizers and from Kaggle, and the organizers get the algorithm and the winner gets the money. So that's how basically this works. It's also, a way of crowdsourcing solutions. And what they do is that this is, by the way, a very well-known data science platform. A lot of data sets are available here. A lot of competitions are available here. It's also, quite addictive in a way because people can waste a lot of time on this. So what they do is that they conduct a survey every year where they talk to all the people who are enrolled on the Kaggle platform, and they talk to those people about their preferences and what sort of working environment they have, what sort of jobs they do they use machine learning or not, if they use machine learning or data analysis, what algorithms they use, what software they use, bunch of different things. So essentially what we're going to do in this particular case study is take the data from this survey and try to see what sort of analysis we can do on that. So essentially this is the file which contains the survey results. Let's read that file. It's a CSV file, which means it's a comma separated value file. We are going to use the read CSV function, again included with pandas, to read that data into a data frame. And let's, as we know, the head function is going to give us the top 5 rows. Let's take a look at that. So there it is. So this basically is our header. It says that I'm looking at 5 rows because I called df.head without any function, and it gives me 5 rows by default. I can change that whenever I want. And it has 246 columns. Why it has 246 columns is because the survey contains a lot of questions. It's a fairly involved and a fairly detailed survey. It will take about a good half an hour to 45 minutes for somebody to sit down and finish the survey. But at the same time, it's very valuable because this is a good way for the data science and the data analytics community to get more information out there about themselves and about the different opportunities and what sort of work people do and so on. So as we see, the very first column essentially is time from start to finish in seconds, and every row is basically one respondent of this survey. So basically, whoever this person was, that person took 510 seconds to fill the survey, and their age was between 20 and 24 years, or 22 and 24 years. That person was a male, and this is one particular question that they did not choose to answer, because this was basically what is your gender, and the option here is prefer to self-describe. Since they've already said they're male, they wouldn't want to take this particular option. They live in France, they have a master's degree, the job title is software engineer. They work in a company where there are about 1,000 to 10,000 employees, and so on. So that's basically the data set that we have. So let's take a little bit of time in trying to understand the data. We already know the shape of the data. There are 19,718 surveys. By the way, when you call df.shape on a particular data frame, it's going to give you two numbers. The first will always be the number of rows, and the second will always be the number of columns. Here also we can see that we have 5 rows and 246 columns, but that's because we only did df.head, and that only lets us see 5 rows at a time. So the overall number of rows is 19,718, which means that in this survey, 19,718 data analysts from all over the world participated. Now, they may not necessarily identify data as data analysts, but 19,718 Kaggle users participated in this survey. So, and we have 246 columns, which are basically a combination of multiple questions that were asked in the survey and all the possible answers that you could have given to that survey. So let's take a look at this. How do we interpret the dimensions of this data? Well, it's obvious. There are 19,718 participants, and there are 246 response columns. Each row is a question in the survey. This option is clearly not correct. It is a participant's response to the survey, essentially. And each column is essentially a question in the survey, and also, the set of all answers given to a survey, given to a given question. So basically, this column, the third column, is essentially the genders of all the people who have participated in this particular survey, right? So how do we get the rows? Let's say that I want to just get the first row. So I set I equal to 0, and I do df.log of I. So that's my first row. Now you see, there is something really funny with this data set. The headers are there, and then in the first line we have the header again. Essentially, you see you have things like Q1, Q2, Q2 other text, Q3, Q4. So essentially the header is basically a bunch of codes that are given to the question. Whereas in the first row, you see that is the verbatim, verbose version of the whole question. This is the question, the text of the question as it appeared in the survey itself. Why they have given codes is that because the questions might become too long, and therefore it might just be easy to refer to them with codes, right? So there is our first column. It's basically the code and the meaning of that question, essentially the question code and the question itself. That's the pairing we have here. Now, how do we get a list of columns from a data frame? We just do a df.columns. So the columns attribute of the data frame variable, which is df, is just going to give me all the columns that we have. And these are all the columns we have. We have time taken from start to finish, Q1, Q2, Q2 other text, Q3, Q4, Q5. Q5 had other text because sometimes you have questions in surveys where it's an MCQ kind of a question, but at the same time there'll be a field called other or something like that, where you can add in free text instead of choosing one of the predefined choices that are given to you. So that's basically captured under the other text column for that particular question. And then there are multiple questions which are, in multiple parts. So for example, we can see here that question 34 had 12 parts. So we can see that there was a part 4, 5, 6. Some of them are not shown here because this is a list which has 246 elements in it, and Python chooses not to show it. We can actually, of course, convert it to a list and actually see the whole list, but that would be too long to parse. And that's why it's more or less meaningless. You can just look at the columns to get a summary idea of whatever number of columns there are. So the point is that there are questions, and some of them have multiple choice answers, and some of them also have free text answers, essentially. So we know how to select a particular column. We just say that my column name is time from start to finish in seconds, and I just get that column out by putting a pair of square brackets around it, and calling it on the dictionary. Just like you get a key value pair out of a dictionary, similarly you get a column out of a data frame. So basically I know that my column is time from start to finish in seconds. I put that string in a variable called call name, and I just access the call name from the data frame, and that's it. So I see that the 0th value is duration in seconds, the first value is 510, and so on, blah blah blah, right? So basically that's the time that every participant took to finish the survey. Now here's a question. How is this column useful to somebody who is analyzing this data? We want to analyze this data. We want to figure out what are the interesting patterns that are available within this data set, which is coming from the responses of data science practitioners from all over the world. So clearly there is a lot of inherent value in this. We might want to see what are their preferences, how much do they earn, what are their qualifications, and so on. A bunch of those things are there. So one of the columns we're considering first is the time column, the duration. Think a bit about how this might be useful. Feel free to pause the video, and when you have thought about it, when you have, say, a couple of ideas about how a duration might be useful in analyzing this data, resume the video. Well, if you think about it, these are survey results, and unfortunately, most of us do not take surveys very seriously. We either just submit them if they are short enough and if it's convenient for us, but otherwise we just skip past them. And you know that evidence for that can be seen here. You see that there are people who have finished the survey in 83 and 84 seconds, which is just even less than 2 minutes. It's barely 1.5 minutes. So for a survey that has about 246 data points to capture about you, there is no way that you can finish that survey properly in 83 or 84 seconds. Some of the other values, yeah, they do look a little reasonable, but at the same time, we see that we have terribly large values as well, 9,195 seconds. So these are probably people who opened up the survey in a browser tab and then forgot about it and only later remembered it and then submitted the survey. So, you know, what's happening here is that we have people who either just opened the survey and ignored it completely, or people who opened it and forgot about it, with of course a bunch of values in between. So let's take a look at what are the minimum and maximum values in this particular column. And that raises an error. Let's take a look at the error. It basically says that less than or equal to is not supported between instance of string and int. So it's essentially, in order to calculate the minimum or the maximum, somewhere internally it has to perform this less than or equal to operation, and it says that it's not supported between instances of string and ints. What it means is that it doesn't know how to compare strings and ints. You know, if you give it a pair of two integers, then it knows one of them is greater than or equal to the other or not. But when some of the columns are strings, that goes for a toss. It doesn't know how to compare strings and integers. And why is this happening? Well, look at, you know, if we can take a look at the first row, you see that the first row is a string and everything else is a number. So what we need to do in order to find the minimum and maximum is basically to omit this particular row and look only at the remainder of rows. So let's try that. So when we see df.head, we see that the entire first row for all the questions is basically just the question reworded, in the sense that our original header is basically just text and the first row is just you know, another piece of text which actually contains the whole questions, and the real data of the survey starts from the first row onwards, not from the 0th row. So what we need to do is omit this whole row and somehow keep a mapping to the headers themselves. So in order to debug this error that we got, say it says that it's a type error, which means a type error usually occurs in Python when you're trying to do operations on things that don't have the correct type for it. And that is actually true over here. So when you do a less than or equal to, it is only supported between two numbers, not between a number and a string. So that's why the type of the variables that you are passing to this operation were incorrect. So let's take a look at the type of this particular column. It says that it's an O type. O stands for object over here. What that means is that it's not integer, or it's not a float, it's not a boolean, it's a string type. Why that has happened is because the first row contained a string, so that is why it casted everything else into a string as well. It did not stop to interpret all of these things as numbers. Now, if we say that duration is simply the call name from the first element onwards, if you remember, this is the syntax we use for slicing lists in Python. So when I say 1 colon, what that means is that take everything from the first row onwards. So let's try that and put that in a new variable called duration. So when we do a head on duration, you see that we have a bunch of things which are now numbers. We have gotten rid of the very first column, which was text, right? And now what we're going to do is use this function called pd.toNumeric to convert this d type of object into a d type of integer. Let's try that. And we see this time we get it correctly. It shows me the data, but at the same time, it's also telling me that the type is int64. What int64 means is that each integer is being represented with 64 bits. Right? So one way to do that is actually to apply a lambda function. Lambda functions in Python are nothing but anonymous functions. They are essentially functions that take a particular value, and whatever you write next to it, that is the value that they return. So essentially it takes an x and it converts that x into an integer and returns it. So what I do is I apply this particular function to each row of duration using the dot apply method. So essentially duration here is my column, and when I do a dot apply of this particular function, what it's going to do is simply take this function and apply it to every single row of that column. And that output I'm capturing in a variable called duration in ints, which is my integer duration. So there it is. So again, as we see, when I do a head on the output column, I get the time from start to finish in integers. One easier way to do that is simply to duration.as type of integer. I can also do an as type of float, but in this case, we are just measuring seconds. There is no concept of half second or something like that. So integers is fine. So let's take a look at this. Now we have that's basically the column we have, which has a type of integer 64. Now, for the first time in all of this exercise, for the first time, we have a column which is purely numerical. And as you know, what we do with numerical columns is do univariate analysis on them. And one of the straightforward graphical methods of doing univariate analysis is to try and build a histogram. So essentially, let's do just that. There it is. That's basically the histogram of our data. That can be done simply by calling the dot hist function on any column in pandas. So basically this was a column, duration in ints, and we just called the hist function on it, and we gave a parameter which is the number of bins that we want to divide the data into. If you remember correctly, a histogram, what it does is that it takes the minimum value, the maximum value, and that range it divides equally into a bunch of bins. And for each bins, it's just going to count how many values lie within that bin. So essentially we're saying that take the minimum value, take the maximum value, divide it into 50 equal bins, and try to just count how many rows there are within each bin. So as we can see from the histogram, lots of values, most of them in fact, on 90% and more easily, are concentrated in the very first bin. So which means that there are obviously a few outliers. Some people took a lot of time to, a very small number of people, but they did take a lot of time to fill the data set, right? So in order to make a little more sense of this particular histogram, we are barely getting any information here. All we are getting from this particular histogram is that most of the data is concentrated in the leftmost bin or the minimum bin of my data. In order to see a little more clearer histogram, what we're going to do is filter the data along this axis a little bit and look at the histogram when we have a smaller range of numbers. So as we know, we can do the filtering with Boolean indices. If you remember how we filtered the name of Emily from the earlier example, we added basically a logical condition like a double equal to operator, and it returned a bunch of true and false values, and we use those true and false values to pick rows from the data set, right? And that's exactly what I'm going to do over here. We say that find those rows in duration in ints such that their value is less than 60. So we are basically trying to find out all the people who submitted or finished the survey in less than 60 seconds. And from that, we are going to calculate the histogram. So let's take a look at this. So there it is. We see that about a little, less than 10 people finished it in 25 seconds, and about 50 or so people finished it in less than 60 seconds. Now, the thing is that all of these people probably didn't take the survey very seriously. So this is, this is some data we might have to drop because they probably just randomly clicked something, and in general, since they finished such a complicated survey very quickly, their input is not very reliable. So essentially, now we are going to use these filters to filter out the entire data set. So what we do is we create a new column called toDrop, which is simply going to contain the index values of all those peoples whose duration was less than 60 seconds. So let's do that. And when we look at the toDrop function created thus, we see that row number 151, 700, 7,844, 10,526, all the way up to 1,900, 19,706. These are basically the row positions whose duration was less than 60 seconds. So if we go back to the data, we see that we have these numbers 0, 1, 2, 3 as our row labels. Now these are the row labels such that their duration in integers was less than 60, and these are the ones that we have to drop. In order to do that, we use the drop method, which is also available on the data frame itself. So what I say is df.drop, and then I give it the values to drop, which is essentially the list of these values, and I say that drop them along the 0th axis. The 0th axis basically means that I want to drop them along the rows, not the columns. So essentially the 0 axis is, since it's a two-dimensional data frame, it has two axes. And since counting starts from 0, the 0th axis is the rows and the first axis is the columns. So we want to drop along this. Along this particular axis, those values don't exist at all. It's the column headers that exist, right? So we can think of this as a little bit of data sanitization, and we want to do it in place. We want to modify the existing data frame to drop these values. We don't want to create a new data frame, right? So we just add that in place equal to true flag over here, which is just going to drop all of that data. And then when we do df.head, we see that we have all the values that are greater than 60. In fact, when we try to do, first of all, if we get the call name, we get the data again. And then when I try to do an ilog of 1 onwards, which is all of these things without worrying about this particular value, which is actually a text and therefore might prevent me from calculating minimums and maximums, then I'm going to convert it into integers, and then I'm going to take a minimum value. And as we see, the minimum value is 60, which means that we are only keeping those people in our data who have submitted, who have taken at least 1 minute to submit the survey. Now, of course, this choice of 60 seconds is arbitrary. You can easily say that, how do we know that somebody who did not finish it in 1 second or 1 minute, 1 second was actually not, was taking it seriously. So this is a completely arbitrary value. You can choose your own. The idea is just to show you how we can do filtering and use that filtering to drop particular rows which you think might be unclean. Now we're going to continue with this data set in the next notebook, and in order to do that, we are going to save the clean data that we have. We're just going calling it clean because we have dropped some rows, which by some definition we have designated as dirty or suspicious rows. In order to save a file or a data frame to a file, just like we did a read CSV, there is also a to CSV. You just give the path to the file that you want, and you say that index is false, which simply means that this particular column, which is our index column, we don't want to write it back because it's just 0, 1, 2, 3. There's no point writing it back. It's just going to infer it back from the data when we read it again. So let's write that data. Now our data is written, and make sure that you actually finish this step properly, because we are going to depend on this clean data in the next video when we do more mathematical and more statistical analysis on this data set.